Okay, so believe it or not, this is already, for me, the last section I lecture on in this chapter. Most of this chapter is lots and lots of examples. So when you get stuck at the end of chapter 8, if you go back there, there's lots of additional examples of calculations. I will be doing these calculations on this page, and I'll tell you like how you can do some other kinds of calculations. But this chapter is short, but it's one of the most important chapters that we cover during this first half of this semester. Okay, so I want to make sure you understand, even though there's just a few problems, really what I want you to do is work them and understand them. And if you can understand it after you do like 4 or 5 problems, do a couple more to practice, do the practice quiz for chapter 8, see how you do. And if you got it down, then you got it down. The exam covers 5, 6, 7, and 8, so this is the last chapter in that exam. There will still be a fair number of questions from this chapter, even though it's short, okay? Okay, so this last section is how to go from grams to moles to moles to grams. So oftentimes you see it written like this. And really it's just a different kind of problem solving that you can do, right? So in this particular problem, you're asked to find the grams of chlorine gas that are needed to produce 150 grams of titanium 4 chloride. So what you need to think about is, in these kinds of problems, when you have grams, really these are problems that have problems inside of them. Okay, it's maybe a lot like we are, but anyways, but they're problems, they're bigger problems made up of little problems. And the little problem, okay, the one that you know already, is that you need to do a mole-to-mole conversion. There's no way to go from reactants to products in this method other than doing mole-to-mole conversions. So then the thing is you have grams on either end, right? So how do you go from grams to moles? And this is why we reviewed this at the very beginning. Think about what we did, right? We used the molar mass. Or if you have the moles and you need to go to grams, again, it's the molar mass. So I'm going to do something here, and I'm going to set this problem up. But first, let's talk about it like this. This is A, right, B, and C. You could have just called them A and B, but in case I need to use it later, I might just call them A, B, and C like that. So I'm given, right, grams of C. And what I'm going to do is I'm going to get moles of C. And then I'm going to figure out, this is the mole-to-mole conversion. I'm going to do a moles of B like that. And then once I have that, I'm going to go grams of B. Now, to make this problem go a little bit faster, these are your molar masses. The units here, these are molar masses. And on a lot of these longer problems, I'll give you those numbers, so look for them, like on a test. A lot of these longer ones, I'll give them to you. Now, a couple of them I won't, because I want you to work through the whole process. But for many of them, I'll just give you the numbers, because I'm not trying to test whether or not you can calculate that. I'm testing whether or not you can do this whole process, okay? So I'm going to say I want grams of B, right? And so I have 150 grams of C. Now, its molar mass is 189.67. So first step is to convert that into moles. So it's 189.67 grams of C for every 1 mole of C. Now, if you want, you can write the chemical formulas, but I'm kind of used to doing it either way. Doesn't really bother me. But I could have written the titanium chloride there for C, or I could have just written C. You can do what you want. And then I need to go from C to B, so I need to get the C's to cancel. So I know it's 1 mole of C for 2 moles of B. And that'll allow me, if you look at what's going on here, grams will cancel here. Moles will cancel here. And then the last step is to get over back to units of grams. And since I have moles of B, it's 70 grams, 70.90 grams of B for every 1 mole of B. Now, a lot of people, sorry about all the noises, by the way, it's my crazy cats going around the table. a lot of people get confused by having this 2 here, and they want to double this molar mass. Don't do that. It just makes it so much more complicated. Just use the molar masses as they're given to you, right? And then use the mole ratios where you're supposed to, and it'll work out like this. Now, just a couple of things about this. There's 3 conversions in this pathway, so there's 3 of these railroad tracks, 3 sets of numbers, right, that are used as conversion factors. So now I can just pull out my calculator, and I'm going to say 150, and I just ignored the decimal here. I should have probably put it in here, though. 150 divided by 189.67 times 2 times 70.9. And that comes out to 112.14 grams of B. So that's how much chlorine gas you would need in order to get theoretical yield of 150 grams of titanium chloride. Now, in terms of Sig Figs on this particular problem, right, I had 4 here, so I should keep 4 in here. The reaction ratios are exact because they're based on those whole numbers, and these molar masses are calculated with generally 4 or 5 significant figures. I can round this answer to the 4, so it's 112.1 grams of B, like that. Now, if you had wanted to calculate moles of chlorine gas, and hopefully this made sense to you, grams to moles to moles to grams. If you needed to calculate the moles of B, right, you would have written moles of B over here, and then rather than completing this conversion all the way through this step, you would have just left this step off, because if you're looking what's happening to units, the C's would have canceled at that point, the moles of C would have canceled at that point, and I would have been left with moles of B. So write down at the very beginning what you're trying to find, and when you get to that point in this gram to mole to gram conversion, just stop, and then you're done. Okay? I'll do one more problem, and then I expect that you'll probably want to go to the book and do a few more of these practice example problems, and then give the homework a shot. Right? This is a limiting reactant and percent yield problem. So let's look at the information we're given. I says how many grams of SO3 could be produced, so we're looking at this, right? We're looking for grams of that, produced from 15 grams of O2 and 15 grams of sulfur S. So immediately when you read a problem like this, if you have more than one of the reactants, you know that for each reactant you have to calculate the amount of product that you'll get, and whichever one gives you the smallest amount, right, that's the theoretical yield. That number is the theoretical yield. And the reactant that gave you that number is the limiting reactant, because that's the one that runs out, okay? So what I'll do is I'll do one of them, and I'll let you do the other one, and then I'll pause it, and you can look and see how you did, okay? So I'll go ahead and do this one for O2. I'm going to do this one without the ABCs, just so you can see it's, for some of these problems, it's not a big deal, but when you see big chemical formulas, it becomes really tedious to write them over and over again. So I'm going to say I'm looking for grams of SO3. Now you're going to do it down here, grams of SO3. All right. I'm going to start with 15.0 grams of oxygen, and you're going to do the one for the sulfur, so 15.0 grams of sulfur, like that. So I'm going to set up my railroad tracks like this, and if you feel confident that you can shove all the numbers in there, just stick them all in there right away. And so for oxygen, it's 32.00 grams of oxygen for every 1 mole of oxygen. And then the mole ratio is 3 moles of O2 for 2 moles of SO3. And then if you're looking at what's going on with units, the grams are canceling, the moles are canceling. So I have moles of SO3 up here, right? So I'm going to want moles of SO3 on the bottom. And so that's going to be 1 mole of SO3 for every 80.07 grams of SO3. Like that. And so I can do my calculation. I'll go ahead and do that, and then I'll pause it, and I'll let you go ahead and calculate your result. So I'm going to go, again, 15. And part of this, again, why I'm showing this calculation on the calculator, because a lot of you can do it, but some people will struggle all semester and like, gosh, should I divide first or multiply first? And so I like to show a couple of examples almost in every lecture just so people can get used to it. So 15, I said, I don't have to put the 0, so I'm going to divide that by 32. I'm going to times 2 and divide by 3. So I've taken care of these right here. And then I'm going to times 80.07. And that becomes 25.02 grams of SO3. Now, you're going to have units of SO3 over here as well, but you'll just have a different number, and you're working from the sulfur instead of from the oxygen. So let me pause this, and then when you start back up again, I'll have the answer worked out for you. All right, so there we are. I have 25.02 grams of SO3 with 3 Sig Figs, and I have 37.45 grams of SO3 with 3 Sig Figs. So the theoretical yield that you could make, right, is going to be this. This is the theoretical yield. This is the limiting reactant, okay? And the limiting reactant theoretical yield always go together. And S would be the excess reactant. All right, so hopefully you got that. And then on this next problem, it's a fairly simple problem. It says if 2 grams of SO2 are actually produced, that would be horrible, right? But if 2 grams of SO2 were actually produced, what is the percent yield? So percent yield is going to be 2, sorry, where's the number? The actual yield, and the theoretical yield is 25.02, and I use the unrounded number, and I'll get back to that in a second. 100 grams, 100%. So that's going to be 2 divided by 25.02 equals 0.799. Not very good. So this number now that I've used it down here, now when you do calculation like percent yield, don't use the rounded numbers, use the unrounded number. The number you'll report if they're asking for this answer would be 25.0 grams as your answer here. And then here, it's only 2 Sig Figs, so I would round this to 0. Sorry, got distracted by something. 0.80%. And did you guys catch my mistake? That was what I got distracted by. If you go back to the calculator, I don't know what I was thinking when I wrote 0.7. I was multiplying by 100 in my head. This comes out to 7.99% and 8.0%. So hopefully you crazy people out there actually see those things faster than I do. I appreciate you guys. Thanks. Anyways, that's it for the chapter. Again, just in the context, I'm doing daily office hours in summer school, and if you want to show up, the hours are posted in Canvas, so feel free to drop in and ask questions. And again, if you have any questions, you can always text me or send me an email.